Welcome back, everyone. So today we're going to look at some more quadratic equations that require us to solve them by completing the square. Okay, so let's just recall when we want to complete the square, we're going to take half of b. Okay, right. So in this case, our b is -2. We're going to have the example x squared minus 2x equal to 1. Here, b is -2. So if I take half of b, I get -1, and then I want to square that value of -1. And so when I square -1, I get +1. Okay, and so here our value of c that we need is +1. And what I do to the left side, I must do to the right hand side. So I'm going to add 1 here as well. Okay, and so I get x squared minus 2x plus 1 equal to 2. And then I want to factor the left hand side. So I get x minus 1 squared equal to 2. And I solve by taking the square root of both sides. Okay, and so I get x minus 1 is going to be equal to plus or minus the square root of 2. And then I need to isolate x. So I'm going to add 1 to both sides. And actually, let's just take care of that off. Okay. Okay, and so when I add 1 to both sides, I get x is equal to, remember our constant comes first, so we get 1 plus or minus radical 2. Okay, and so that is our solution. Okay, now let's look at an example where a is not 1. So here we have 4x squared plus 8x equal to 21, and we want to solve for x by completing the square. So we're going to do the exact same thing that we would if a was 1, except the first thing we're going to do is we're going to pull out the GCF of the left-hand side. So the first thing we want to do is we want to factor out the GCF of the on the left-hand side. So factor out GCF on left-hand side. Okay, so when I do that, I get 4 times x squared plus 2x, and that's equal to 21. Okay, and now I'm going to just follow the same steps that I did to complete the square when a is 1. I'm going to take half of b. So in this case, our b is now 2. If I take half of that, I get 1, and then square it, it still remains as 1. Okay, so I'm going to insert that value of 1 on my left-hand side. But now, when the number that we are to write on the right-hand side is not going to be 1. It's going to be 4, because we have to remember that we factored out our greatest common factor. So when we add that value of c on the right-hand side, we must put back in that greatest common factor. So here I'm going to add 4. Okay, and so now I'm going to just continue as I'm going to factor the left-hand side. So this becomes x plus 1 squared. And on the right-hand side, I'm going to get 25. And now I'm going to solve using square roots. So I'm going to divide by 4 first to isolate my x. Okay, and so I get x plus 1 squared on the left-hand side equal to 25 over 4. Okay, and now I'm going to take the square root of both sides. So when I do that, I get x plus 1 equal to plus or minus the square root of 25 over 4. Okay, now on the right-hand side, we want to take care of this square root. So remember, we're going to use the quotient property of radicals to separate our radicals. So we get radical 25 over radical 4. So that gives us x plus 1 equal to plus or minus the square root of 25 is 5, and the square root of 4 is 2. So we get plus or minus 5 halves. And now I want to isolate my x by subtracting 1 on both sides. Okay, and so I get x is equal to -1 plus or minus 5 halves. Okay, And so now I want to separate into my two cases. So the first case I have is that x is equal to -1 plus 5/2, which is going to be -2/2 plus 5/2. So one solution is that x is equal to 3/2. And my second solution, I'm going to have x equal to -1 minus 5/2. And so here I get x is equal to -7/2. Okay, and so to finally write my solution, I'm going to write in set notation. And so I'm going to have -7/2 and 3/2. Okay, let's take a look at one last example. Okay, so now here I have 3x squared plus 8x equal to 5. Now, the first thing I'm going to do is I'm going to pull out my greatest common factor. But here, notice 3 is prime. So 3 and 8 have a greatest common factor of 1. So there's nothing for me to pull out. So what I'm going to do in order to make this, remember the goal on the left-hand side is to make it a perfect square trinomial. What I'm going to do is remember that in a perfect square trinomial, A has to be a perfect square. So in order to make 3 a perfect square, I'm going to multiply it by itself. So on the left-hand side, I'm going to multiply by 3. Okay, and so that's going to give me 9x squared plus 8x, and that's going to be equal to 15. Okay, and sorry, let me put my 3 here as well. Okay, now we're going to continue as if we were trying to find the value of c that makes this to complete this perfect square trinomial. So I'm going to have b/2, which is going to be 8/2, which is 4, and then I want to square that value. So I'm going to have 4 squared, which is 16. Okay, so I need a value of 16 to make this a perfect square trinomial. So I'm going to have 9x squared plus 8x plus 16, and I'm also going to add that 16 to the right-hand side. Okay, and so when I factor this, I get 3x plus 4 squared is equal to 31. And now I'm going to solve using square root. So when I take the square root of both sides, I get 3x plus 4 is going to be equal to plus or minus radical 31. Okay, and now I want to isolate x. So the first thing I'm going to do is I'm going to subtract 4 from both sides. So I get 3x is equal to -4 plus or minus radical 31. And then lastly, I need to divide by 3. Okay, and so my final answer is going to be x is equal to -4 plus or minus radical 31 divided by 3. Okay, and so this is the solution to our equation. All right, and that is the end of today's lesson.